with technology.
That is. Yeah,
Um,
having a little technical difficulties.
yeah. Okay, so Jaden, do you want to tell us what
Yes.
Celsius is?
Uh, like the.
Like,
What do you mean by tell us what it is?
well, here, maybe a better question is what's the difference between Celsius and Fahrenheit?
Uh, Fahrenheit is what I guess the US uses to use temperature, and ask me why. I could not tell you the benefits of using Fahrenheit. Celsius is what most of the world uses. It's a little nicer, right? Because freezing is at 0 degrees, boiling is at 100 degrees, or Fahrenheit, you have 32 degrees is freezing and 212 degrees is boiling. So I don't I don't know why we use Fahrenheit, honestly, but we do, and probably will for a while. Uh, what are your thoughts about that, Kip?
I think you're right. I feel like at one point I knew where Fahrenheit came from and what the purpose behind it was, um, but I can't remember right now.
Yeah,
Um,
it's like unimportant. That's how it is. It's just not necessary.
yeah, it is. And then, but the idea behind it is that there are we got a comment from Kelsey saying, because I'm different. Yeah, I'm different. That is a reference to one of the best songs ever out there by 2 Chainz. Anyways, Kelsey
Yeah,
hates that song,
sure.
just in case anyone's wondering. Also, for all you people chatting out there in our chat to each other, get to know each other, and ask as many questions as you want as we go along, just in case you're wondering. We
Yes,
love getting your
please.
questions. We love listening or reading what you guys have to say because it makes it better for us as well.
Makes
Okay,
it more interactive. We have
yeah,
a lot more fun with it.
exactly. Jane, I want to figure out why your video is so delayed and I can't figure it out.
Yeah, sorry guys.
I don't think it's on your end. I think it's mine. Okay, all right. So back to here we go. So just really quickly, there's different scales of measurement out there, right? And for different things, we've talked a lot on here about, for miles versus kilometers. And there's different scales, and they have their different benefits.
Right.
Most people would argue that there's not a lot of benefits to the American systems. And wow, I just got a comment because Kip's hot, not because Jaden's hot, because Kip's hot. So take that, Jaden.
Well, hold up. Kelsey just mentioned my name. We might get something else. We're just waiting.
Oh, hey Hunter, how hot am I in Celsius and Fahrenheit? Let's see if you can do some conversions.
A scale of 1 to 1 billion.
Am I
Rude.
boiling hot?
Okay. Anyway, I'll just be offended for a split second. Ugh! Okay,
Maybe it's
I'm
your
back
audio
now. I'm
that's
ready.
lagging. Hmm.
So that'd be funny.
Okay, or maybe it's just my
Okay, but
side that's
anyways,
lagging. All right. Anyways, let's get back to this. Okay. So different scales used for different things. Like Jaden said, we use Celsius to describe a scale from 0 to 100 is why we use it, and it's based off the idea of water, right? So 0 is
right.
icicles, um, and 100 is boiling hot. Okay, so it's at what temperature water freezes and what temperature water boils, becomes a gas, right? So the state change of it. Fahrenheit, on the other hand, I don't know what 0 represents or 100 or why it's there, but it's there for a reason. There's a third unit out there that is very common, which doesn't even have a degree sign, I don't believe. I'm pretty sure it's just Kelvin. It's not degrees Kelvin. I think it's just Kelvin.
Yep.
Oh, here we
Yeah,
go.
just
We got
Kelvin.
more comments though coming in. What do they say here? We got,
Whoa.
he doesn't appear to be lagging to me. That's good to know. I think negative 4,000
Doesn't.
degrees because it's the same in both Celsius and Fahrenheit. That is incorrect. It's actually negative 40 degrees, and we will talk about that in this video. But close, Hunter. You're very close.
um, negative 4,000 degrees. I don't think that's possible, Kip. Do you think
Yeah, I
that's
don't think so
possible?
either. No, and we'll get into that here with the Kelvin scale as well. Uh,
Yeah. Good.
so the Kelvin scale is based around this idea of absolute zero, right? So 0 degrees Kelvin is the coldest anything on the planet can get to. Um, and the
Right.
Kelvin
And
scale,
at that,
yeah, go.
sorry,
No, go.
but at that 0, right, that's like no energy exists at that temperature. So there's no movement, no heat, no nothing.
Right.
So maybe that is how we can stop time.
That maybe works. We have to time travel. We'll teleport while being frozen, so we'll go the speed of light, but be at absolute zero, and so maybe then we won't.
Yeah, I think that would work. Okay, but anyways, continue.
Anyways, so Kelvin scale and the Celsius scale actually change at the same rate. So if 1 degree Kelvin changes, or 1 Kelvin changes, then 1 degree Celsius changes. However, it's just off, or it's set differently. So 0 degrees Kelvin, I believe or 0 degrees Celsius, I believe is 273 degrees Kelvin, or 273
Yeah,
Kelvin.
point something, right?
Yeah. No, it shouldn't have a point because, like I said,
Yeah,
the scale is perfectly. It's just offset. So, anyways, right? Or I guess it could be offset by a certain amount. Yeah, you're right, Jin. It could be point
yeah. I
something.
think if you change by one, they both change by one, but I think it's
Right.
like
Yeah, there is something in
point
there.
one something. But
But anyways, we're not
yeah,
talking about Kelvin in this video. But Jane, you also did bring up an interesting thing. What do all these
uh-huh.
measurements actually represent? You were talking about energy with Kelvin. So what
Right.
does a degree, what does temperature actually represent, and why do we even care about it, I guess? We use it all the time. We
Yeah,
know if something's hot or cold outside, but what does that
right.
actually
Uh,
mean?
th- that's a good question. It means like how much energy an object actually has. Temperature is just basically a reading on how fast your molecules and atoms are actually moving. So really, there isn't like hot and a cold. It's just like how much heat an object has. But that's, I don't know. No one actually thinks like that. So you'd be like, oh yeah, it's cold outside. But in reality, you'd be like, oh, there's some heat, but less heat than I would have in the summer.
Right. Uh, yeah. So, I mean, when you talk about it, it is the movement of particles, right? It's how much energy these
Yeah,
particles have, and because these particles are moving so fast, they give off heat energy, and that's kind of what degrees represent. And that's why if you're at absolute 0 Kelvin, the particle has no energy. It's so cold that it is stagnant. It is not moving.
Right.
And some really, really crazy physics happens down around absolute zero. You get superconductors. You get all sorts of really neato stuff. Um,
Yeah.
anyways, go watch videos on superconductors because they're super cool. That's how you get things like maglev trains.
That is cool.
Let's see here. I got a comment
Wild stuff.
that I can't read. It says, "Ha ha, Hunter, they just called you out for being wrong. It's less heatful outside than it was when the sun was out." Yes, that's absolutely right. And that's because the energy of the sun is no longer on the earth. Well, it's on the earth, it's just on the other side.
That
Um,
side of the earth. Yeah.
so, anyways, so yeah, that's why things get colder when the sun goes away. It's because that energy is gone, and some of the molecules on every, in the air and everything cool down. They stop moving as much. All right, let's get back
Wow.
to Celsius versus Fahrenheit. And we'll talk about
Okay.
Kelsey's question that she had today. I think maybe I want to go to a new slide. Are you good with that, Jane?
Sounds good.
Okay.
Yep.
And I think what I want to do is draw a graph. Okay. So I'm going
Ooh,
to
that's a
put
graph.
this graphing
Spooky.
paper. And again, we've talked about graphs briefly, but graphs are meant to help visualize math, help visualize things that we may not be able to normally understand otherwise. So I hope my
Right.
visualization, if my pen will draw.
It's doing excellent, Kep. Your pen is drawing.
It is? What's it drawing, Jaden? Because I
I
can't
see a
see.
line.
Yeah, but do you see a horizontal line? Because I'm trying to draw a horizontal line and it's not. Oh, there you go. Aha.
Oh, I just see the vertical line.
There we go. There comes the horizontal line.
There we
Okay.
go.
So I'm going to go ahead and draw a line going like this. And this is not going to be to scale, but that's perfectly okay. And it's going to start at 0, 0 and work its way up. And it's going to have a slope of 1 to 1. Okay.
Ooh, I like it.
And this is going to be degrees Celsius. All right.
Okay.
I'm going to change colors, even though I know I have the blue, but I'm going to change to red because red's hotter than Celsius. So, you got the blue and the red. And anyways, cool. So now, Jaden, quick question. If this
Okay,
is
I'm ready.
0 degrees Celsius at this point at the origin, right?
Yeah.
What is our Fahrenheit going to be at that point?
We'll be at 32 degrees Fahrenheit.
So, I probably how should I do this? Oh, I'm trying to think here. How I wanted to do this. I think I wanted to keep Fahrenheit in terms of Celsius. So we'll mark on this graph what I'm saying. So this is, here, erase this, and we will call this guy 0C, right? And we will call it 32F, okay? And so Jaden, now if we were to remember, and we're going to call this up here 100C, okay? This graph ain't to scale, but that's perfectly okay. Again, what did we say that it was going to be at? How was I going to do this? Was I
I don't
gonna
know.
have to have
What
two?
do your actions represent?
Dude, I'm trying to figure that out right now. Um,
um,
okay, maybe. Okay, I'm trying to think here. Um, I think I need two axes is what I need to do. Um,
yeah, you might have.
is that the way to do this?
So the
I'm trying to think here because this is gonna be also this is gonna be um 212 F. Um, so come on. When Kip's brain works faster than he can keep up with. Yeah, that's what's going on right now. I go down these paths. I'm like, yeah, this is a great idea, as we're working through this stuff, and then I get to a point, and all of a sudden, I'm like, wait a second, I don't think that works. But it should work.
yeah.
It's just a matter of trying to figure out what exactly it
Are
is
you
I'm trying
saying
to. What I'm trying to get is I'm trying to
is
get
our
two lines.
y-axis? Yeah, is our y-axis temperature and our x-axis is like
Maybe
how
that's
much energy we
maybe
put into it, or what's going on?
I I think I found the issue, Jaden.
Okay.
Let's think here. Um, aha. I think. Okay, well, I'm just gonna write this out real quick. Spoiler alert. Fahrenheit equals
Spoiler.
C times um, one. What is it?
Nine,
It's like I'm
nine
trying.
fifths
Yeah, nine
plus
fifths
32, right?
plus. Yeah, that's right. Um, okay, so according to this equation, then we could make our x-axis C and our y-axis F. But that's
Okay.
not what I wanted
So we
to
got.
represent, though. Um,
Oh, wouldn't it be? This would be F, and that
yeah,
would be
that's
C, and that's
yeah,
C.
yeah. But that's not what I'm trying to represent here. I want to show the growth of these two graphs together, um, and show how there's kind of
Uh,
this scaling difference between the two of them, right? So we need an equation for C
right.
and we need an equation for F, I think, is what my issue is. That they're independent of they're dependent on the same variable.
We
So
could relate
maybe
both of them to Kelvin.
that's what I'm thinking we do. I think that's what we got to
Yeah.
do. Um, but we want um, yeah. So in this case, F would be equal to C plus 273, right? Um, times 9 fifths plus 32, and Kelvin would equal, or Celsius would equal,
Wait a minute.
that's a K, not a C, right? Is that what you're gonna say?
It'd be Yeah, it would be K minus.
No, to get to C, you add 200, right? Because when K, no wait, yeah, you're right, it's minus. Ugh, my
Yeah,
brain.
yeah, yeah. It's all good. We're struggling together, having fun.
Yeah, we are. Okay, like that. Um, Now, will this work if
Sweet.
we make our, hmm, so now we want our y-axis to be Kelvin though, I think.
Yeah.
that right?
Yes. Because we could have Kelvin and then we could have like
We could
Celsius
compare
and
the,
Fahrenheit.
yeah.
Yeah.
Mm-hmm.
Yep. Then we'd
Well,
have Celsius and Fahrenheit both on the x-axis, just overlaying each other. Right?
I think so. I think that that's, but then we're still going to get this issue where at the origin point we'd get 0 Celsius and 32 Fahrenheit, and they would keep this similar trend, right? They would stay on top of each other.
Well, now we wouldn't really need any of this stuff. Because then we would just say Kelvin. Oh, wait a minute. If
Do you get what I'm saying?
Kelvin was 0, your Celsius is going to be like 273 or negative 273. Hold up. We need the negative.
No, wait, no, I think I'm, no, um, I think I do want to leave this as, yeah, for what I'm trying to represent, I think we do want to leave this as K.
Uh,
The x-axis is going to
okay.
be K, I think, and let's just draw it.
X-axis. Okay.
Yeah, and y-axis will be F and comma C, I think. I think that's,
FC.
yeah. And we'll, so, okay, so we're at 0C, right? And that means we're
Right.
at,
Okay. Yeah.
and this isn't actually an origin point. This is actually when K is equal to
207.
273. Okay. So K, and so our F is equal to, we'll just throw it on here somewhere, 32. And
Should we make it a yellow?
why not red?
Oh yeah. Isn't it C's blue, sorry.
Yeah. You can make
Well,
Kelvin yellow,
yeah.
but we gotta change
Dude.
this to, okay. So we got 32, and then to get to this same Kelvin, it's gonna go up like this, and this is gonna be at 212, right? Dang it, now I'm yellow.
Right.
Jaden, you
How did
confused me.
Dude. Okay, this was very well practiced, as you can tell.
This is, hey, you know what, Jaden? This is the point of these videos, in my personal opinion, right? Our goal
Sure.
is to show people that even though we have degrees, right, we don't know everything, and we have to think through things. And that's what we
That is
hope
true.
you guys can take away from this, is that if you don't know how to answer a problem right off the bat, that's perfectly normal, and it's what
Yeah.
you're supposed to do. And this
Yeah.
way, we're showing you how we go about problem solving, and this is what I
And
do.
so far, we're doing great.
We've got a comment from Kelsey that says, "I don't trust this graph because you guys didn't even find the slope." We're not quite there yet, Kelsey. We're gonna get there. This is a visual representation of what's to come, so
Yeah.
calm down.
Okay.
Okay. So here's the deal, Jaden. Are you noticing something about the slope? I'm actually glad she brought it up. What's the difference
Dude,
between?
yeah.
So what are you noticing?
Well, the slope of Celsius is less than the slope of Fahrenheit.
Aha. So now if we come this way, back a little bit, boop. Oh, my line's off. Boop. Guess what's going to happen? There's going to be a point at which Celsius and Fahrenheit intersect each other, right? And as Hunter pointed out, there is a point when the two are equal. And then after that, because of the slope of the two lines, what are you doing there?
Well, that would be the 100 degrees
You're right.
Celsius.
Let's erase this.
Yes.
Yeah, you're right.
Yeah,
I ran out of
just helping
space to
out.
keep going up. Okay. Um, and so any point after they intersect,
I have
right?
put the degrees in the wrong spot.
All of a sudden,
Okay.
okay. Um, your line was
Yeah.
never right because you didn't graph the actual slope. This is a visual representation, Kelsey. So this
This is
doesn't
a
need to be
visual
perfect,
representation.
right, Jaden?
Right. Which now that we have all of this on the graph, we can help explain our struggles.
Right. So if we notice
Okay.
at this point, Jaden, what happens? What's going on to the right of that point where they intersect, and what's going on at the left of that point where they intersect?
So it looks like Celsius will be, I guess, greater than Fahrenheit before the point they intersect. And then after that point, Fahrenheit will be greater than Celsius. That's what I'm reading. What about you?
That's what I'm reading too. So yeah, anytime that we go to the right of that point, uh, or as it gets warmer, right, Fahrenheit is gonna be a bigger number than Celsius, and anytime we go left at that point, anytime we get colder, Fahrenheit's
Uh-huh.
actually going to be less than Celsius. Um, so let's see here. We've got this equation written out, Kelsey, the one that I am going to circle or box right now. Kelsey, can you tell us what the slope is?
Hmm.
Now, I'm asking Kelsey because she's been commenting so much about the slope. Let's see
I
if she can.
know. Hmm.
What is it gonna be?
Hmm.
Or if anyone else
Kelsey.
that's watching, if you know,
Yeah.
let us know. What is the slope of the line of f equals k minus 273 in parentheses times 9/5 plus 32?
Hmm.
We've got it's x divided by y. Jaden, do you want to uh, take that? Because
Okay. I might understand what you're talking about. Uh, but slope, like maybe when you're learning it in middle school, the slope is the change of y over the change of x. That might be what you're thinking of. Um, so you're wrong because you have an x over a y, and we're not using x or y in our situation. We're using
she,
f and k.
she's
Um,
she's asking, do you want an actual number? The answer is yes. We do want the
oh,
actual number for this equation.
yes.
Sorry, I guess we didn't specify.
Ooh, Tip.
What?
This is actually a tricky question.
I know. That's why I know. Darn. Um, yeah, I'll give Kelsey a few more seconds here to think through it. Or anyone else. Again, I don't know how many current viewers we have, but that's not important right now. What is important is if you do know the answer to this question, I don't remember how to do that. All right, Jaden, what is it?
Okay, at first glance, I would say 9/5.
I would agree with
Okay.
you that it is 9/5.
Okay, but the weird thing is the K minus 273 in our situation,
Right.
right? Because that's in parentheses and you could distribute the 9/5 through. That's why I was saying it could be tricky.
Right. And we can go through that. So really quickly, what Jaden's talking about is in math, we normally have this equation, which is y equals, in a linear equation, y equals mx plus b, right? Where
Right,
m is your slope and b is your y-intercept where it crosses the y-axis. Um, but we don't have that in this case. Our k in this case is our x, and our f is our y. But the thing that we do have is that minus 273 in there that isn't there in a normal situation. But Jaden, if we were to distribute this out, right, and put that
yeah,
9/5 in here
oh,
and
did
there,
you copycat?
then what would happen is, right, we would get a constant, which would then add to the 32, which would become our
Yeah,
new b, and we'd still have a k times the 9/5. So the slope is still 9/5, right? And as
right.
Kelsey almost got right, that equals the rise, how much the y value changes in comparison to the x value, right? Or in our case, how quickly the Fahrenheit changes in comparison to the Kelvin value.
Kelvin. Right.
Um, all right. Since Kelsey's the only one that is commenting, should we go ahead and ask her to find the slope of this next one?
Yes.
Of c equals k minus 273. And remember this equation, y equals mx plus b. And remember k equals x and y equals c.
Ugh.
Helping out much?
What was that?
You helping much there?
I don't think so.
Not at all. Maybe we've lost Kelsey now
So,
too. Maybe we're viewless at the moment. But that's all right.
we're having a great time.
We are having a great time.
I think
Um,
she'll be answering if she does any moment now. I betcha. She says, "What?
what? I didn't see that. Why isn't? Oh yeah. What? What is the slope? That is the question.
What is your M? What is the
M.
slope of the sea line?"
Um. Anyways, Jaden, what is it? Let's.
Okay, so the slope in this situation is 1.
Okay.
And if anyone was paying attention when we first started, when Kip drew this diagonal blue line, he was like, it's a 1-to-1 ratio that I'm going for. So that was kind of a hint at the beginning also.
Yep. It sure was. So, Jaden, that being said, just really quickly here,
Yeah.
um, we, I guess the question is 9/5, the slope of 9/5 is, here, I'm going to write this, m equals 9/5, and over here we're going to say that m equals 1, okay? 9/5 or 1, which one do you think is bigger?
Or 9/5.
Killing it. And so that means that, right, that's why you have this bigger scale, say from 32 degrees to 112. And so, same, and that's why from 0 degrees Celsius to 100 degrees, right? There's a bigger gap um, between 32 and 112 because the slope changes so much more. Okay, or it's such a larger slope. And then the other thing that we can see from this graph, Jaden is right, in this area, we see that this spread only gets bigger and bigger, right? So the hotter and hotter we get, the difference between the two temperatures, between Celsius and Fahrenheit, actually gets bigger and bigger.
Right.
And the same thing happens down here, where our Fahrenheit gets smaller or more negative quicker than our Celsius does. Jaden, here's
Yeah.
a question I have for a mathematician.
Okay.
So if you're in the positive realm, as you get closer to 0, you say it becomes smaller and smaller. Once you cross and become negative, do you still say that's getting smaller and smaller? Is more negative considered a smaller number?
Um, yes. But I guess that's depends on what kind of like math you're doing. If you're doing like number theory, you don't really deal with negative numbers. Um, if you're dealing with like applied math, you'll see negative numbers in like physics and higher math like that. So I don't know. It's just they are smaller and smaller, but in a different way.
Okay. Thanks for that. All right, so
It's weird.
it is weird. Math's weird, but I never know what to say. So I stick with it gets more negative faster, right? I stick with saying more negative because
Yeah,
I feel like
it's a bigger negative.
yeah, because I don't feel like it
Yeah,
fits into that smaller category, right? I feel like as you approach 0 and
yeah.
your numbers get smaller and smaller, but when I'm writing out answers and stuff, I never know if it's okay to put it gets smaller.
Well, like in calculus, you have limits that like approach infinity or
Right,
approach negative infinity, right?
exactly.
So it's, or
So
they
there,
approach zero, and
right.
it's like all of those are just, it's just different.
It is just different. Okay. So talking about this graph, Jane, should we go ahead and figure out what that point is?
What this
Where,
point is?
yeah, where they're equal to each other?
Yeah,
Okay. And how do we
we
do that?
should. Well, we definitely need the two equations,
Okay.
right?
Right.
Um, let's see, we read. Oh, we just gotta set them equal to each other, Kip.
Yeah, we do. So I'll write here, let's see if we can meet in the middle. I'll write the Fahrenheit side and you can write the Celsius side and let's see if we can get them to equal each other.
I. You mean like
Never mind, I'll just write them
over
both.
here,
Yeah.
and then write this?
Yeah.
Well, I wasn't sure where you were gonna start,
I
where you
know,
were
that's
gonna
what I was saying. I
end.
was gonna see how it worked out.
Gotcha, I gotcha, I gotcha.
Okay, so you want to take lead on this?
Sure. All right. Yeah.
Let's see if
Okay.
you, what way you approach it.
I'm just gonna go ahead and add 273. Oops. Whoops. That was like a dyslexic moment. Sorry.
That's all right.
Okay. If you can read that, raise your hand and follow me to the next page. Is that all right?
That's all right.
I don't
But I'm
think
making
we're
it black.
gonna. Okay, so we were at 2k minus 273 times 9 fifths plus 32, and then I said I'm going to add 273. That's going to equal k. Okay, we'll go from there. Whew! Draw a little line. Got to rewrite all this fancy stuff. Kip, do you want to start distributing the 9 fifths into this?
Well, Jaden, the way I was gonna
Or do
do
you
it,
think there's a different way of?
I wasn't gonna have to worry about distributing the way I was gonna do it. And so I don't really want to.
Oh, well, I guess we still.
I, if you add that 273 back over, I was gonna divide both sides by k minus 273.
So, but then you'd have to divide the 32 by k
Oh,
minus
you're right.
273.
Dang it. Never mind. Okay, you're right.
But I like the thinking.
Oh, you're right. I realized the error as I was saying it because I realized then I wouldn't have a variable and that would be bad.
Yeah, that would be
Okay, I'll distribute. So we
that
got
would be
9
no
fifths
solution.
k minus 9 fifths times 273. 9 times 273 is going to be what's that gonna be? That's gonna be a 7 or yeah, 7. That's a 2. Carry the 2. 2 times or 9 times 7, Jaden, is 63. But you got a 2, so that's a 5, and then you got a 6. Or a 2 times 9 is 18, plus 6 is going to be 2 for that.
Nice, and then we need to add the 305 to it because that's a negative number right now. And guess what you get?
What do you get?
Negative 186.4.
Negative 180 what? 6.4?
6.4, yeah.
Cool. So we've got,
Okay.
well, here, we'll erase all this nastiness. I'll make it look prettier.
Magic.
Okay, where do we go from here?
Okay, now we need to get our variable on one side.
Okay.
So we can minus the 9 fifths k on both sides. So then we have a negative 186.4 equals a negative, what would that be? Negative 4.
Oh, I missed a math magical apparently. I'll throw one in. We haven't really done
Would that be
anything like
negative
that.
4 fifths k? Yes.
1 minus 9 fifths, that's 9 or 10 fifths. Yeah, I think you're, no, wouldn't it be positive? Positive
No.
4 fifths? Yeah. 10, or,
What?
oh yeah, 5 fifths. Okay, never mind. Dude, ignore me. Ugh, my brain's going. Again, students
Okay.
out there, this is normal to struggle, see?
So we get a really, really cool number here. So now we have to divide by negative 4 fifths. Divide by negative 4. That's a 4 fifths. And guess what k equals?
What does k equal?
233.
233.
Yep. That is where our temperatures are the same, Fahrenheit and Celsius. But
And
now we should
that's
probably
convert to something that people know.
convert to, yeah, convert to one of them. Okay.
Which one do you want to convert to?
Dude, I'll do the Celsius. It looks nice.
Okay. I agree with you. It does look nice. Um,
Should we go to new slide?
yeah, go to new slide. Sorry,
Okay.
I'm handling a comment that I got, which was saying that Mickey just subscribed and there was nothing happened. So I'm trying to figure out why, because it definitely should have. So
Cha. Oh,
I'm getting
wait.
to the bottom of that while you keep going.
Okay. Have you switched to the new slide
No,
on
I
the?
haven't. Sorry, I need to do that. Thanks. I
Yeah.
forget that what I have to control that and you can't. So
Okay. Uh, all right. So we got K equals 233. So this side I'll do the Celsius. This side will do Fahrenheit. So our fancy equation for Celsius was C equals K. Oh, yeah, K minus 273. So all we have to do is plug in what we got for our K. And it looks like this. 233 minus 273. And like Kip said earlier, we have a negative 40 degrees. And that's in Celsius.
what would it be in Fahrenheit,
Okay.
Jaden? Quick trick
All right,
question.
now our fancy Fahrenheit equation. We have F equals, what was it again? Something with 9/5. All right. K minus 273 times 9/5 plus 32. Okay. Now we got to plug in K again, our Kelvin. So we have 233 minus 273 times 9/5 plus 32. We get 40 times 9/5 plus 32. And that equals 72. Wait, is that I'm missing a negative right here. That's a negative 72 plus 32. And that equals, drum
Negative
roll please,
40.
Kip.
Oh,
Oh.
sorry. I ruined it. Whoa, Jaden, they're the
Oopsies.
same. Isn't that weird?
Whoa. How did that happen? Oh, right. We just explained all of that with our fancy visualization graph. Go check it
Exactly.
out.
Wow. Dude, guess what? That is mathemagical, and
That was math magical.
that's solved. Boing!
Solved. Woohoo! Are
Okay,
there any questions out there?
yeah, any questions? To answer Kelsey's comment about Mickey just subscribing, I'm not sure why, but YouTube or somewhere has not updated the fact that that subscription has happened. Um, so,
Huh.
let's just, Jaden, I want to take it one step further here,
Okay.
and talk just to prove that other part of the graph. We know that, like, you said, or that we talked about, 0 degrees is 32 degrees Fahrenheit. But what happens on the negative side? I'm going to go or past negative 40. So Kelsey asked about
Okay.
negative 50 degrees today, right? And so really
Okay.
quickly, I'm going to go ahead and cheat something that I realized we could have done quicker as far as our math goes now. I knew there was a shortcut in everything that I wasn't thinking about. But if we remember, C equals K minus 273, right?
Yeah.
And we wrote over here F equals K minus 273 9/5, right, plus 32. The reason why I
Yeah.
was able to know this formula is because I knew what it was times C, so I just plugged in what C was, right? And so we can revert back to that, and we can actually write F. So because we have K minus 273,
Yeah.
and we have it on both sides, we can just simply say that F equals C 9/5 plus 32, right? And so that's
Right.
a quicker way to compare the two. Anyways,
Okay.
so we used the K for the graphing, but now that we want to compare the two directly, this is an easier option. So Jaden, if C equals negative 50, then we can go and say F equals negative 50 9/5 plus
Uh-huh.
32, right?
Okay.
Okay. And
So
then
then we
for
would get a negative
that's negative.
58.
We'd get negative. So how Jen did that is you can cancel your 5, so you get F equals negative 10 times 9 plus 32. F equals negative 90 plus 32. Therefore, F equals negative, what'd you say? 58? 48?
58. Yeah.
Wait, yeah,
58.
58, yeah. Dang, I was
Yeah.
close. When we were talking about it today, guess what I said? I said it'd be
What did you say?
I said it would be approximately negative 60 degrees.
Oh,
That's what I said. No joke. That's
that's pretty
legitimately what I
close.
said.
That is wonderful.
So
Look
notice,
at you approximating really good.
yeah, look at me. So notice that because of that, right, when we get to the more negatives, after past negative 40, the negative Fahrenheit actually grows more negative, negative Fahrenheit grows quicker than the negative Celsius. So it actually seems colder at a certain point. Anyways, so there you have it.
Yeah.
After negative 40 degrees, it becomes more negative quicker. Before negative 40 degrees, it becomes more